I want everyone to close their eyes for 1 second and try to imagine a new color. It's hard, isn't it? Well, that's because as humans, we only see color in 3 dimensions, red, green, and blue. But this mantis shrimp over here can see 12 dimensions of color. Why is that? Why is that this one animal has these superpowers while us humans don't? Now, this is not a new problem, and this has captured the minds of scientists for hundreds and hundreds of years. In fact, even Charles Darwin, who theorized evolution, had the hardest time convincing and explaining to people why and how eyes evolved. But in 2024, we actually know quite a bit of information. We know how it all started. Thanks to advances in biology, we know that it started 500 million years ago with light-sensitive bacteria, cyanobacteria, which evolved over millions of years to the diverse life form that we see today. In fact, we can think of this as a movie starting 500 million years ago, and there's a direct relationship between all the animals and our early ancestors. So what we don't know is what happened in the middle. And evolutionary biologists have tried to piece together this very important puzzle using fossils, present-day species, and living artifacts. But there's an issue. The issue is that these fossils don't paint the full picture. In fact, only 1% of all species that have ever existed are actually fossilized. That's like working with 1/100th of the data, because the other part of the data simply doesn't exist. So, can AI help us fill these gaps? But in fact, can we go further? And can AI start to create this whole evolution computationally from these building blocks of life to the diverse animals that we see today? So, biologists communicate that these building blocks are made of the eye primitive, the eye building blocks, which are proteins that are light sensitive, and a brain building block, which are these neurons. And what we have done is create an artificial version and computationally replicated these to create artificial building blocks for the eye and the brain. What we can do now with these artificial building blocks is simulate what these ancient bacteria saw the world. And it's not a lot. These are light-sensitive bacteria that are kind of trying to understand and navigate the world. But we can go further. What we can do now is we can simulate this in the same way biology did, by co-evolving their eyes and their brains. And what we get is something like this. First signs of artificial vision. What these first creatures would have seen interacted in the world. But we can actually start to go further. We can continue this process and start to finally see what the first insects saw the world. And finally, we have something that kind of looks like us. So what we have essentially done is start to computationally recreate millions of years of evolution in these finite GPU hours. This is an important problem because this is going to lead to us figuring out how natural intelligence and natural evolution happened. And I postulate that by creating these digital twins of natural evolution computationally can help us figure out the most important movie of our lifetime, which is the movie about the evolution of our very own eyes. But why stop here? We can actually go further and simulate the impossible. What if humans had the eyes of a mantis shrimp? Or what if we could put mantis shrimp on Mars? How would these eyes evolve? Thank you.